we're going to be taking a look at the quadratic formula. So here is an interesting idea. Wouldn't it be nice to solve any quadratic equation by plugging in the coefficients, a, b, and c, into a formula? Does a formula exist? And if so, how can we prove it? So what we can do is we can complete the square on the equation ax squared plus bx plus c and solve for x. Now we basically take this equation right here and we complete the square. Now, where should we end up? We should end up solving for x, and the final answer should be x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So part of the reason I'm showing you this is it might be your first introduction to a mathematical proof. Secondly, if we have a formula that can solve all of our problems, we should know where it comes from. So what I'm going to do is I'm going to complete the square to solve for x. Now, I have this I have this equation, ax squared plus bx plus c is equal to 0. The first order of business I'm going to do is just going to pretend a, b, and c are just numbers. And what would I do with those numbers? Well, I would isolate the x's first. So simply, I subtract c to both sides. The next step I would do is I would take this equation, which is a very nice equation, and I would divide both sides by a. So essentially, I'm going to make leading coefficient one. So I'm going to divide the left-hand side by a. I'm going to divide the right-hand side by a. And what comes out is I should have x squared plus b over a x is equal to negative c over a. So the x's are isolated to one side. My coefficient in front of the x squared is 1. So now I'm going to complete the square. So I have x squared plus b over a x is equal to negative c over a. So if I have the coefficient in front of the x's b over a, well, how can I complete the square? So in my little aside box here, this is where I have all my thoughts. I'm going to take b over a. I'm going to divide that by 2. Then I'm going to square it. But instead, what I'm going to do is I'm going to do something equivalent. Did you know that dividing by 2 is the same as multiplying by a half? So b over a times a half is b over 2a, and then I need to square it. And what that will yield, the term that I need to add to both sides, is b squared over 4a squared. You square the top, b squared. Square the bottom, 2a squared is 2a. Squaring that is going to create 4a squared. So that's what I'm going to add to both sides. And I really love math proofs because it really helps me think and clarify what's going on. In my proof, I need to start here. What's my final destination? My final destination is this. I'm getting closer, but I don't really see any way that this is immediately going to change to that. However, do you notice that on the right-hand side, we have a b squared term? Well, let's continue working at this a bit. So I'm going to factor the left-hand side. So I'm just going to write factor left-hand side. So if I factor the left-hand side, well, this is x plus, what was the number that I squared? B over 2a squared. So things are starting to shape up. Now, on the right-hand side, well, I have a constant. Really, I'm adding two different fractions, and I'm just going to write it like c over a plus b squared over 4a squared. Well, I know if I need to, if I'm going to add two fractions, I need a common denominator. So I'm just going to create a common denominator. The common denominator would be 4a squared. So how do I turn a into 4a squared? Well, I need to multiply both top and bottom by 4a. So the left-hand side is going to be b squared over 2a squared. And the right-hand side is going to be 4ac all divided by 4a squared. Now, I made a slight error there. I forgot that this was negative c, so it's actually negative 4ac plus b squared over 4a squared. Now, this is shaping up. If you take a look at your destination, the destination that we're trying to get to is proving that the equation ax squared plus bx plus c is equal to 0 will have solutions at negative b plus or minus the square root of b squared minus 4ac, all that divided by 2a. So if we look at the left-hand side, or sorry, the right-hand side particularly, right here, you can almost see b squared minus 4ac. So in fact, let's just reorganize it so it looks like this. So I'm just going to write common denominator. So in a mathematical proof, it's always good to know where you are, but particularly where you're going. Because sometimes you can sort of take a guess of what you might want to do mathematically. So on the right-hand side, I'm just going to reorganize it so it's b squared minus 4ac all over 4a squared. The left-hand side is going to be x plus b over 2a and square. Next thing I'm going to do is I'm going to take the square root of both sides. So if I take the square root of the left-hand side, it's just going to create x plus b over 2a. And the square root of the right-hand side, don't forget to consider both positive and negative roots. The square root of b squared minus 4ac all divided by 2a squared. Just make sure that it has to go all the way to the bottom. I swear we're almost there. Maybe you can start to see where everything's shaping up. If you take a look at the denominator and you consider just for a second, wouldn't it be nice if that was 2a? But for some reason, it's not. But let's take a look at the right-hand side. Well, the top remains as b squared minus 4ac. Now, the bottom is actually a perfect square, 4a squared. So you can take the square root of the bottom, and that is 2a. Now, the left-hand side is just going to be x plus b over 2a. Oh my God, I feel like we're there. So if you want to, I could write simplify denominator of right-hand side. Now, maybe I'm just going to move this down one step. It would be certainly nice if I had one more line. There we are. So I just created one more line for me to have. And what I'm going to do is I'm going to subtract b over 2a to both sides. And if I do that, wouldn't you know it, I have quadratic formula. By the way, that right here is called the quadratic formula. I have derived the quadratic formula. And what I get is, since I have a common denominator, can just simply put the numerators together. Negative b plus or minus the square root of b squared minus 4ac all over 2a. What did we just do? While it was maybe necessary evil, these things come up for a reason. Did you know that an equation in the form ax squared plus bx plus c is equal to 0 will have solutions when x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a? So I suppose, getting back, we have a magic bullet that will solve any quadratic equation, and all we have to do is plug in the coefficients of a, b, and c into the quadratic formula.